An extraordinary experiment conducted on the surface of Mars has demonstrated the potential to produce breathable oxygen from the planet's extremely thin atmosphere. This remarkable achievement is thanks to the Mars Oxygen In Situ Resource Utilization Experiment, MOXIE, a compact instrument tucked inside NASA's Perseverance rover. MOXIE has repeatedly broken down the molecules found in the Martian air to generate a consistent and sustainable supply of oxygen. Now, let's understand the significance of oxygen on Mars. The ability to produce oxygen on Mars holds immense importance for future human exploration and colonization efforts. Oxygen is not only vital for astronauts to breathe, but also serves as a critical component of rocket propellant. Developing the technology to harness Martian resources like oxygen is crucial for establishing a sustainable presence on the red planet. MOXIE is designed by MIT scientists from the Massachusetts Institute of Technology and has been actively operating since NASA's Perseverance rover landed on Mars in February 2021. The experiment aims to assess how MOXIE functions under various Martian conditions. It does this by running multiple experiments over time, each simulating a different scenario. Over 16 runs, MOXIE has successfully generated a total of 122 grams of oxygen, enough to sustain a small dog for 10 hours or a human for 4 hours. MOXIE employs a process known as electrolysis to separate oxygen from the Martian atmosphere. Here's a step-by-step breakdown of how it works. First step: air filtration. MOXIE draws in Martian air through a filter designed to remove impurities, ensuring a clean input source. Second step: compression and heating. The purified Martian air is then compressed and heated, preparing it for electrolysis. Third step: solid oxide, electrolyzer, SOx. The compressed and heated air is directed to the solid oxide electrolyzer, where the magic happens. The SOx uses an electric current to perform an electrochemical breakdown of carbon dioxide, CO2, into its constituent atoms, carbon monoxide, CO, and oxygen ions, O2. Fourth step: oxygen recombination. While carbon monoxide is vented, the remaining oxygen ions are recombined to form molecular oxygen, O2, the type of oxygen essential for human respiration. And final step: quality control. Before the produced oxygen is released, its quantity and purity are measured to ensure it meets the required standards. Each MOXIE experiment takes several hours to complete. It involves a warming-up phase, followed by an hour of active oxygen production. During this productive hour, MOXIE can generate up to 10 grams of breathable oxygen. To put this into perspective, this amount of oxygen can sustain a single astronaut for about 20 minutes. While the theoretical oxygen output looked promising on paper, MOXIE's actual performance exceeded expectations. During its 16th run on August 7th, it successfully extracted approximately 9.8 grams of breathable oxygen, coming remarkably close to its targeted goal. This achievement underscores that even in the extremely thin Martian atmosphere, a reliable supply of oxygen can be obtained. Even in a worst-case scenario, a device like MOXIE could supplement other sources of oxygen, reducing the amount of oxygen that needs to be transported from Earth for future missions. Based on the lessons learned from MOXIE, scientists are now focused on developing a comprehensive system. This system will include an improved version of the oxygen extracting device, techniques for liquefying the gas, and a method for efficient oxygen storage. But don't pack your bags for Mars just yet. There are many more things to figure out before we can live there. Getting oxygen is just one piece of the puzzle. There are lots of other challenges, like staying safe and having enough food and water. However, MOXIE's success is a big step in the right direction to help us explore and maybe even live on Mars someday. I hope you enjoyed watching this video, and if you are interested in more content like this, please consider subscribing to explore. These videos might catch your interest. I highly suggest that you watch them.